Okay, and again, welcome everybody to this ManyBabies workshop on multiverse analyses. And here's our presenter, Giulia Calignano. Giulia, take it away.
Yeah, thank you very much, Heidi, Queen, and all the ManyBabies Consortium to accept this proposal for this workshop. I'm very excited because it's, I think, a very hot topic. And so I will start sharing the slide. You should be able to find the slide in the chat via a link that I hope Queen will put in there. So you can follow also by following the slide. Okay. Oh, okay. I think you can see now the slides, right? Okay, so yeah, this ManyBabies workshop of multiverse so starts with So it's a way to navigate this multiverse thing that is around in the science community from a while. I'm Giulia Calignano, as Heidi nicely said, and I'm from the University of Padova in Italy, Department of Developmental and Social Psychology, and I'm proudly the coordinator of the Psychostat group, that is an interdisciplinary group of psychologists and statisticians, and we aim to link the two science in order to make more credible both sides. And even because as a psychologist, we use a lot of statistics. So it's very important to collaborate also in an interdisciplinary way. So yeah, after this little piece of advertising for Psychostat, this is the outline of this workshop. So the first part will be more on the philosophical principles and guidelines of the multiverse approach. I hope not to be too annoying in this part, but I think that's very important because otherwise it becomes harder to understand why we implement all these analyses on a single dataset. So it's very important to bear in mind the aim of all this effort, this collaborative effort. In the second part, I will show you how we implemented the multiverse approach, the exploratory multiverse approach, analysis on the ManyBabies 2 Pupillometry project, that is a spin-off of the ManyBabies 2. First of all, let me start with a big thanks to the incredibly collaborative people that populate the ManyBabies Consortium, and in particular, I want to thank Melanie Schreiner, Alvin Tan, Marlena Meyer, Robert Epach, and all the ManyBabies 2 team, because not only believe in this idea of doing this crazy multiverse on multilab datasets, but also work a lot together with me in a very truly collaborative efforts. And it was great. And it still is, because we didn't finish, the work in progress is still on. So, part one, philosophical multiverse approach. So what is a multiverse analysis? I think that many of you knows, but for those of you that doesn't know what is a multiverse analysis, we can start from this very famous, let's say, table by Brian Nosek, that briefly indicate the 4 columns, let's say, of the new open science direction. So we can have a dataset and a pipeline of analysis. This is maybe the most common situation, and it becomes reproducible once we share datasets and code, and everybody can exactly reproduce the exact results that we publish in our work. But when we have, let's say, different datasets are investigating the same research question, and we adopt the same pipeline of analysis, then we are looking for replicability of the results. That is, even if we change a sample, for instance, maintaining very identical the experimental paradigm, the question, the measures, and so we end up with different data sets, and we apply the same pipeline that we adopt to our first data set. If we get the same results, then we gain a replicability of the results. But we can also have the situation in which we have data sets, but different possible, plausible pipeline of analysis. In this case, if we end up with the same results, with the same interpretation of the results, then we can say that the results are robust. And when we are able to apply different pipeline, plausible pipeline of data analysis to different data sets that, of course, investigate the same specific phenomenon, at this point, and only at this point, we can get generalizability. So the multiverse analysis try to focus on robustness. So try to apply to a same data set, in this case, a data set, a multilab data sets, different plausible pipeline of analysis in order to get robustness, an indication of how our results are robust or fragile. I mean, they are complementary terms on a continuum, robust or fragile results. That is, if the results is there, or if the result just depend on the arbitrary choice that we did during our data analysis. So what is a multiverse analysis? Is a systematic exploration of all reasonable analytical paths. This reasonable part is very important because it's not that analysis in the multiverse analysis just take all the possible paths toward a result. It depends on the tradition and of a specific scientific field. The aim here, if you decide to adopt a multiverse analysis, is not to say if a result is there or not. So we are going beyond significance. And on the contrary, or complementary, the multiverse analysis enhance transparency and systematically organize researchers' degrees of freedom. Indeed, I started to be passionate about this multiverse approach to data analysis when I was a PhD student and I was alone in my room, in my office, and I discovered that just changing a little branch in the pipeline of my data analysis may result in a dramatically different results. At the first time, I was like shocked and I said to myself, okay, Giulia, you are not doing a good job in research. Then talking with other colleagues, I found out that this fear, this problem, this issue of obtaining very different results depending on the pipeline or during the data management also and data preprocessing is a very common thing. And so multiverse analysis allow to embrace such uncertainty, this is part of science, and try to systematically organize these degrees of freedom. And the multiverse analysis can also be seen as a garden of analytical forking path, but importantly, they should be grounded in theory. So again, method here, so of course, we are talking about method, a methodology to how to preprocess and analyze data, of course, but it's very important to be reminded again that here methods is just a tool. It's not a shortcut to arrive to the truth. It's just a way to systematically organize the uncertainty that we found in our data, especially in infants' data, and try to tidy up, to organize, to manage such uncertainty guided by theory, of course. I remember you, if you have comments along the way of this workshop of questions, also provocative one, do not hesitate to ask me because I mean, I think that this is the art of science discussing. So why it matters, why multiverse approach matters for developmental science? So first of all, because of its universal applicability, so we can, there is no one way to do a multiverse, okay? It depends on the specific degrees of freedom in specific field, research questions, methods. So I will show you an application on the ManyBabies to Pupillometry, so using eye tracking basically, but we can translate this logic, this very logic, to any possible methods in any field. So also qualitative studies can implement a multiverse approach, and it's especially suggested in these cases in which uncertainty is even a bigger interesting issue. So the multiverse approach has also a flexible implementation. And what I mean with this is that we can do both exploratory and confirmatory multiverse analysis. Today, I'm going to talk and to show you our effort in carrying out an exploratory multiverse analysis. Another thing that may be very important, specifically in this historical moment, is that the multiverse approach, as a philosophical and methodological approach, aims at enhance the credibility of our science, because address all the replication challenges that we have seen in the NOSEC table before. Last but not least, this kind of approach also aligns with the ManyBabies principle. Indeed, it fits with goals of transparency. We share all the analytical path and rigor, because we should justify each choices during this multiverse implementation. So the guiding principle are thinking before testing. Indeed, we spend like more than 6 months meeting with Robert Epach as a leader of the ManyBabies 2 Pupillometry spin-off, but with all the big group, the great team of the ManyBabies 2 Pupillometry spin-off. And so multiverse force you to think. And to think a lot during the steps that sometimes we do not precisely report in our publication, like the data preprocessing and data management phases. So all the choices are evaluated before data collection, and very nicely we can simulate data and try to implement our pipeline, our multiverse pipeline, on simulated data in order to see, evaluate the feasibility of our multiverse approach. And then when we are sure about the logic, we can collect data and be quite sure, sleep well at night, knowing that our approach makes sense in a way. The guiding principle, another guiding principle, is the theoretical grounding. So not all possible way of trait data are accepted. Of course, we should confront ourselves with a specific community field, and that's very, very stimulating, because you learn a lot as a methodologist from different traditions of how people treat data or define construct. And by using such an important expert knowledge, together we build the multiverse pipeline, the specific multiverse pipeline for each study. Also, multiverse, as you already understood, I think, requires complete transparency. So we should present all the plausible paths that we implemented. It's very important because it affects directly the multiple comparison problem. So if we make the multiverse explode, we end up with many results coming from a single dataset. And the more path we add, the more branch of this multiverse analysis we add, we increase the problem of multiple comparison. So we should be very transparent about that. And also the multiverse approach needs computational implementation, use tools. In my case, I use R basically to implement everything, and GitHub to share the code and also this slide. So as I said, there are at least 2 types of multiverse approaches in terms of statistical modeling or statistical thinking. The first one, that in my view, the most important, is the exploratory methods that focus on identifying patterns and generate hypotheses. Indeed, we know that science proceeds like this. We first explore, and once we have explored enough, then we are ready to have specific hypotheses. So the first step should always be, especially in those fields in which there are no common shared ways of treating and pre-processing data, it's very important to spend good time exploring and before make an inference. So we can do it with the regression of effects plots, with summary indexes, percentages, or visualization, graphical representation of our data, depending on which branch of this multiverse. But we can also run an use the multiverse approach to make inference. To make inference about which universe within the multiverse is indeed the one that is most plausible or useful for us in order to have sounding interpretation of our results. So in this case, we focus on maintain statistical rigor while exploring variation. So the exploring part is always there. I mean, it's a very important part, even in the inferential approach. And here we have, for instance, post-selection inference. That is a very new tool that using a sigma-flipping score test allow us to, in a way, make inferential decision after we run our exploratory multiverse. So another very important role that plays the multiverse is addressing, as I said, the credibility crisis. So we now have this problem of peaking. So this problem in which we selectively report just one path, one possible way to analyze our data. And this, of course, undermines integrity because we don't know whether this specific universe that may comes from a tradition from a specific lab, but still is just a universe in the wider community, scientific community, is indeed robust enough. And so it makes us sleep well at night. Another problem is arcing. So make hypothesizing after seeing the data, the results. So it's like in a postdoc as priori questionable research practice. So the solution to these two problems offered by the multiverse are there, that multiverse transparency, of course, make all the choices feasible. So we have no more the problem of selective reporting of just one significant result coming from a specific pipeline. And also, in a way, make peaking legal because we explore all these paths. And so we show, we show and share all the results coming from all the different paths, but in a systematic and transparent way. So can be life-changing for many fields in psychology and in developmental psychology. At least in my view, of course, I'm a fan of multiverse, so of course I say that. The multiverse landscape. So which kind of degrees of freedom of issue we encounter when we pre-process our data? I mean, these are some points that came up to my mind and also thanks to my experience. But if you have more points that may are ambiguous, that needs disambiguation, that you think that can dramatically impact the results in your specific research field, please share with us. So one that I think is very common is the data inclusion exclusion in terms of participants. Should I include or exclude this baby that makes that have a lot of noise, for instance, in this or her data set, or what to include? So which trial of a baby? Maybe some trial are good, other are less good. We know that we can choose some criteria. So this good, not good in terms of including or excluding data can, of course, derive from some criteria, but we know that there are many criteria. And so we can include all these criteria and see whether this impact the results if we include or exclude participants depending on different approaches. Also, we know that there are a number many pre-processing methods in terms of cleaning, transforming, filtering, baseline correction, and so far, so on. So again, selecting just one way to treat, to pre-process our data may do not tell the full story about the robustness of our results. Very important, it's also the variable operationalization. So that is that relies to how specifically we define a construct. We know that, for instance, in developmental psychology, sometimes, or I don't know, proportional looking, or also pupillometry, sometimes we have several proliferation of constructs and way of operationalizing the measure. And so it can be very informative to collect all this tradition and try to see whether all this way of treating the construct of interest and the measure that overlap, that should overlap with the construct, if all these difference lead to the same result or not. And of course, the statistical models, which one we choose, which one and why. For instance, to make a very specific example, in developmental science, we know that individual differences are indeed very important, play a big role. Yet the majority of studies use ANOVAs. We know that ANOVAs, analysis of variance, do not take into account individual variability. So that doesn't mean that ANOVA are not good, okay? It depends, but it's very important to justify why. And thanks to the multiverse approach, we can also select a set of statistical methods that may are sounding, like ANOVA, a mixed model, a linear mixed model, a nonlinear mixed model, and see whether, no matter which statistical model I choose, the results point to the same direction. So again, gaining robustness. So after all this talking, I just wanted to show you a colorful picture. This is a specification curve. It's a way to visualize the multiverse. How can we interpret this graph? So here you see it, the curve, the specification curve. Each point represents the estimated effect coming from each universe of our multiverse. Here we can see the estimate of the effect that worked as an effect size in a way. And for instance, in this simulated, with simulated data example, we see that each universe actually end up in a very different estimate of the effect of interest. And also those that are on this side of the graph point to a direction. So let's say A is greater than B. But if we look here, so in the bottom part of the curve, the interpretation of a result should be actually the opposite. So that's, I think, a very smart way to in a glance, visualize the robustness of our, or the fragility of our results. And nicely here, you can see the different degrees of freedom. So I don't know, exclusion, participants exclusion, baseline correction, missing data treatment, or this degrees of freedom, of course, depends on you. As I said before, we decide these degrees of freedom before collecting data together with experts of the field. And so we can see, we can actually appreciate which degree of freedom may impact the most our results. Another way to visualize the multiverse that I found very, very informative is the volcano plot. This Janus face. Janus was a god, a Greek god that had two faces. And as you can see here, we have a double phase plot. Here we have the fold change of the magnitude of the effect, again, like the estimates, more or less, the interpretation. Here we have the p-values coming from all the universe, in our multiverse. In gray, we have p-value that are not significant. In red, we have p-value that are significant. You see the opposite direction because we have the logarithm of the p-value. This is made in order to make the visualization better, because otherwise the distribution of p-value is very it's very narrowed. So here, for instance, again, this plot is based on a data simulation, so it's not real data, but plausible data. I mean, a simulation based on real data. And here, if this is our ending point of our multiverse, the conclusion that we should draft is that our results are indeed not at all robust, right? Because we should expect at least that all our p-values and effects size belongs to the same part of the graph, right? Fall on the same area, and they should be way closer. Instead, we see that basically across all the multiverse, we can basically find everything. So it becomes very, very informative. And if I had time, I will show you a shiny app that interactively allow us to, for instance, click on a point here and see which model is this one. And so discuss together with the community again whether this specific path of pipeline may be dramatically drive results or not. So not only the multiverse inform the gold standard of methodological practice, but also the theory can inform also theory in this sense. Okay, so the first part is finished. So if you have questions at this point on the philosophical part, I'm happy to answer. Otherwise, I will continue by showing you the specific case of the application of the exploratory multiverse approach on the ManyBabies 2 pupillometry case. There is a typo here, but okay, typos are everywhere. Multiverse learn. Also, it's good because teach us that problem issues are everywhere, and it's okay. They are treasures because they allow to be better next time. So, okay, so I will continue. So let's see first the study I'm presenting you. So it's a cross-lab pupillometry, a study with over 30 labs worldwide. We have 2 age cohorts, toddler and adults. And the main hypothesis regard this three-way interaction condition per outcome per time modeling. And the multiverse approach that I'm going to show you directly, let's say, derives also in the logic. It has been built in the code, in our code from this paper. So before starting show you navigating with you into the multiverse of the ManyBabies 2 pupillometry, I just briefly remember the ManyBabies 2 project, what is about. So of course, you know better than me, maybe theory is about the theory of mind in infancy. Everything starts with the very famous paradigm with Sally and Anne, in which the idea is to see whether participants are able to take the perspective of an agent that is acknowledged or ignorant in respect to some event. So in this case, for instance, there are Sally and Annie, and then Sally put something here and goes away, and Annie changed the location of the object. And when Sally come back, we usually ask participants where Sally is going to look for her object. And of course, the theory of mind expects you to know that Sally is going to look for the object where she left it, because she was in an ignorance condition in which she didn't know that N changed the location of the object. So in the ManyBabies 2, they implemented this very logic in this way. So first of all, like in many cases in infant studies, as you know, we have a familiarization trials in which there is a bear that chases a mouse many times. This is repeated many times, and each time the mouse goes down this tube, and then the bear always chases the mouse. Then in the test trial, we can have two conditions, one in which the knowledge condition in which the bear knows where the mouse is. So here the mouse is here. So then the mouse changed location, the bear is still there. So the knowledge condition as in the Sally and example. And we have an ignorance condition in which the mouse changed location and the bear wasn't there. So for the ManyBabies 2 Pupillometry spin-off, we just focus on this phase, okay? This very last phase in which the bear coming down in the tube, and we look whether infants are surprised or not to see the outcome interacting with the two conditions. So these are the two areas of interest, the mainly two areas of interest when we expect a surprise-like response from infants. Of course, I'm not an expert in this area. I'm just a methodologist, but I'm trying to do my best to explain this very, very important study. So after the ManyBabies 2, we decide that it was mainly based on oculometric measures like looking times, latency, or so basically oculometric measure and behavioral measure. We decide to Robert Ebert and the ManyBabies 2 Pupillometry spin-off team decide to, first of all, pre-register our secondary data analysis that focus on pupillometry data that, of course, are collected automatically by the majority of eye tracking. So, but they weren't used in the ManyBabies 2 project. You will find the pre-registration on Open Science Framework, and as soon as possible will be public the project on GitHub with all the code to reproduce all the analysis. So as I said before, this is basically the factorial design that we work with. So we have the knowledge condition and the ignorance condition and the outcome. So the bear can emerge in the same box as the mouse or in the empty box, right? So this is the full factorial design we are interested in, and we are just focusing on the test trials. Okay. So the main aims of this spin-off are to investigate responses to goal, as I said, goal congruent and goal incongruent outcomes, and to see whether the child is surprised if the protagonist, the bear, acts incongruently with the goal. The measure of interest here are pupil dilation looking time in our spin-off, but I'm just going to talk about pupil dilation and pupillometry here. Yeah, as I said, everything is registered. So the first step that we make toward this project was the simulation of data. So data collection of the ManyBabies 2 completed in 2023, and data would have been available for us after stage 1 was in principal acceptance. Our analysis, as I said, focused only on the second test trial, and we started with data simulation. That this simulation of the data are very important for the feasibility of all the multiverse architecture. So this data simulation mirrors the expected data structure it allows us to precisely pre-register the analysis strategies. And it's quite important given that this is a secondary data analysis. So being precise about how we are going to treat data are very important, because in the case of secondary data analysis, we in principle can give a look to data. And so this can importantly impact the choices that we make during our data preprocessing and data analysis. So it's very, very, I would say, it should be a gold standard to simulate data before, see whether all the architecture and pipeline of data preprocessing analysis works, and pre-register it, and at that point, see the actual data and implement everything on the actual data. Of course, real life is much complicated that good principle. So it can be that once we see the data, something does not fit. So we have to deviate from our registration, but that's totally fine. We know that, so it's not a real problem. On the contrary, I found that deviation when we explicitly describe our deviation from the registration, we are doing a very elegant work, and we are really getting insight about the science process. It is not perfect at all. Still, it's useful and insightful. So such simulated dataset includes participant CD, simulated, the 2-age course, the time duration for each trial, the y-epsilon coordinates, the pupil size left and right, so 2 columns, and the lab ID, of course. So we have here, for instance, it's very important to notice that we have 2 levels of nesting. So we have the nesting at the individual level, the nesting at the lab level. So that's already insightful in terms of thinking which statistical method is the more adapt to model this kind of nested data. And of course, we simulated the condition and the outcomes that are the 2 main factors in our in such design. So the multiverse structure that we implemented have 5 forking dimensions, so 5 degrees of freedom, 5 forking paths. They are all synonymous. The pupil plausibility, so the filtering of implausible or close to implausible data value. The gaze within screen, that is, we filtered out those points that do not specifically belong to the area of interest. So we end up with 2 datasets, one dataset that include all the data points we collected, or ManyBabies 2 collected actually, and one dataset in which we include only those data points that correspond specifically to the area of interest. We use the filtering moving average, that is basically at the trending process. So we select a window, the average of a window, and we smooth the pupil values across time according to this one. So again, we end up with 2 datasets, one with the moving average filtering and the other without it. And we implement as a 4th degrees of freedom of our multiverse, the baseline correction. We know very well there are no guidelines, not gold standard in developmental psychology that specify, for instance, the length of the baseline correction. And so we decide to use 3 levels of baseline collection, one long baseline, a medium baseline, and a short baseline. Of course, in this case, as in any case, it's very tailored what we mean with long, medium, and small, because it depends on the specific paradigm. Also, as a last point, we include the participants exclusion. So we use 3 different criteria. No criteria, so we decide in the first datasets to include all the babies, no matter what. And then we decide to use 2 selection criteria according to the selection criteria adopted by the ManyBabies too. So to see whether this choice of including, excluding participant according to specific criteria do have an impact on the results. So just to show you the simulated data. So here we have the density plot of the pupil size simulated data for each of the possible combination in our factorial design, as you can see here in the legend, and the pupil size with more or less a median of 5, 4, 5, 6. That is quite plausible in terms of human physiology. So the first degrees of freedom that we encounter, as I said before, was this pupil plausibility. So here in this graph, you see the time and the pupil size in millimeters. And in red, we see implausible values, implausible, but still plausible, but very rare in the human physiology. So we know from very old books of statistics that even if we have a large amount of data, but we have influence cases, they can have values that are very far away from the main distribution. They can dramatically impact our results. So we decide to signal which of these values are extreme, so below 2 millimeters, above 8 millimeters. And we end up with two datasets, one that include all the data and one that include only plausible data, to see whether the implausible data have an impact on the results. So starting from one dataset, we end up with two. Here, you can see the actual data, just a picture, because we are still working on that, but to show you the amount of real extreme, let's say, more than implausible, maybe extreme is the best way to define them, extreme value for adults and toddlers, and you can see, and it's quite fit with my little experience, that the majority of extreme values are usually below 2. And we can see here that the majority of data, by the way, are plausible. So let's sanity check, first of all. And then we will see whether this few group of extreme data may have an impact on our results. The second degree of freedom is the filtering, as I said, of the area of interest. So here, for instance, let's imagine that we have data point, all these points are data points, or are, sorry, data, collect data, gaze points. But may we be interested in see whether just the data points of the very corresponding to the area of interest tell the story about our experiment, or whether all the points actually are useful in order to collect evidence to answer our question. So again, we end up with this time 4 data sets, one that includes just data points in the area of interest and the whole gaze point. Here again, spoiler, these are real data coming from the ManyBabies too, and this is the filtered data set. You see, and again, just visualizing it is already a sanity check, right? Because it really tells us the story of the bear that is chasing the mouse on left and right. And so just visualizing already tell us that our measurement did what it meant to do. So infants looked where we expect them to look. So and in this case, we decide to just take these two areas of interest in one dataset and all these data points in the whole dataset. So to see again whether data points here, for instance, may introduce noise or impact our results compared just focusing on data on the very area of interests. So the third degrees of freedom is the average filter. So as you can see, it has an impact of smoothing of the trending. So here we see the raw data for, again, these again are simulated data, this one. And so we can see that in this line, this smoothed line are the smoothed line that came out from the average filter. So we again end up with two different data sets. One with moving average filter, that is a practice that I never used in my previous experience, but I learned that many labs around the globe use it. So again, Multiverse allow also to recollect and reconcile several traditions in a single pipeline to see whether it is useful or not useful to actually encounter that specific path in the pipeline. So finally, not finally, actually, we have the degrees of freedom 4, that is the baseline correction that allow us to make everyone starting from the same points very correct. And so it's make as we know very well in psychophysiology, it allows us to compare participants, even if they, from the starting point, may have some individual differences. Let's imagine we don't have all the same pupil diameter, so as a starting point. So the baseline correction, this one is a very, very important part in any psychophysiological study, as we know. And yep. And so we decide, as I said before, to apply 3 different baseline, a short, a medium, and a small, a short, a medium, and a large baseline, in order to see whether the length of such baseline have an impact, again, on the results. So as a spoiler, this is real data from just one universe, not the whole multiverse. And you can see here how data look like after the baseline correction. So we end up with 56 plot like this coming from 56 different universes in our multiverse. Finally, the fifth degrees of freedom, that is participants' inclusion and exclusion criteria. So we have 3 criteria. Here, for instance, we see with the second criterion derived from the ManyBabies 2 original study, we see how the distribution of our data change according to including or excluding. One may say that the change is not relevant, not important, that this step is not going to have an impact on the results, but the best things to be sure about that, including in our multiverse pipeline, and see if actually this moving of median has an impact on the final results. Okay, already told you about this, but I want just to put it here again because this is how, like, at this point, we can visualize all these degrees of freedom in this specification curve that you are already familiar with. And so to see, we can see here each model that belongs to a specific branch of our garden forking path, and see whether the estimate change or not, depending on which degree of freedom. Again, these data are simulated. I'm not here to talk about the results of the ManyBabies 2 Pupillometry, just the methodological approach, the multiverse approach. And it's very important because we started from the simulation before seeing that analysis. So it's in a way we are sharing our previous experience in doing that. Again, the Vulcano plot, and so you now may get more the sense of what I meant at the beginning, the first time that I show you this graph, after actually having in mind all the steps that we encountered during the multiverse approach. So, in conclusion, the explorative multiverse analysis show how results shift across processing path, so reveal their fragility or robustness. The multiverse reveal consistent versus fragile effects, and help us, another error, okay, another typo, nice, help us shaping a new culture of error. So that's perfect that I make a typo exactly in this line, because embodied, I say, in psychostat, that is again the group, the interdisciplinary group that I work with, but also of course in ManyBabies. So embracing uncertainty and be sure that knowledge comes from discussing error, not hiding it. And so multiverse allowed this in a very, very systematic way. Yeah, and this is aligned with the suggestion of the paper, my paper, and of course the very magic paper of Stigen that I really encourage you to read it if you don't already, because it's very, very clear and talks in a very philosophical but clear way about the multiverse approach. So next steps. Will be implement also generalized additive mixed effect models in our analytical multiverse. That is, so far we are implemented ANOVAs and linear mixed effect models that have one shared problem. They are linear, so they impose a linearity on our data. So we don't know if the results depend on this linear imposition or on the actual results, the actual information in the data. So we are going to also run generalized additive mixed effect models that are non-linear mixed effect models. We are working on a Shiny app, so everybody can interactively touch the data and explore the data. If I have time at the end of this presentation, I can show you this Shiny app I'm working on together with a great ManyBabies to Pupillometry team. And the next steps, thinking, I mean, in 10 years is to move towards a consensus for a transparent and reproducible data management and processing, because it seems that we really care or really focus on the statistical modeling, that is the very last part. But as Gelman used to say, garbage in, garbage out. If you don't care about data before statistical modeling, statistics is not magic, is not going to give us a good solution. So multiverse allow us to share the tradition across laboratories and build up a shared and full of experience also across the globe pipeline of data pre-processing in a collaborative multi-lab efforts. That is exactly the aim of the ManyBabies. So some references, Stigen, as I say, this one is a very piece of knowledge about the multiverse. I really recommend it. Dragicevic, that shows some way to explore the multiverse in more interactive and transparent way. Simonson, of course, that published the specification curve analysis. So if you want to learn more about the specification curve analysis, this is the paper. Yeah, of course, this is mine. And then we implemented already in a collaboration in developmental science, also a multilab, a multiverse approach across a multiverse approach, because we were several groups, blind groups that ran the analysis on the same data set. I specifically ran a multiverse, so it's like a multiverse in a multiverse. Very nice. Yeah, this paper is the post-selection inference in multiverse analysis. Is an important suggestion if you want to know more about the inferential multiverse analysis. I just talk about explorative, but you can do actually inference on that specification curve, let's say. So see which one of these many universe is significantly different from the others. So, and stay tuned, because we are working on a book with tutorials to run exploratory inferential approaches. Thank you very much. I don't know if there are already questions, or if you want me to briefly show you the Shiny app. We are working.
Yeah, thank you so much, Giulia. That was really fascinating. A lot of this is new to me, but very, very exciting. If anybody has any questions for Giulia right now, please use the raise hand reaction. Otherwise, I would love to see the Shiny app. So while people sort of gather their thoughts, yeah, if you would please show us that, that would be great.
Yeah. So, yeah, for those of you that use R, should be familiar with this. So we have this app here, at this point, very famous specification curve with degrees of freedom. Here we have the volcano plot of this different simulated data. And if I click on this, something should happen. Try also here. Okay, if I click on a specific point of the plots, here the app tell me which exact model I've clicked on, because I'm never sure. And voila, you see the interaction plot that come from that specific universe in the booking plot. So you can see, so I'm working to make this Shiny app more usable, together with the group, coordinated by all the group, of course, and make more useful for the community in order to enjoy the multiverse and not be scared by uncertainty, but actually enjoy it. Yeah, it's very fast.
Very cool. Well, I have a question just to, I guess, kick things off. Do you have any either preliminary results or just hunches yourself about which of those degrees of freedom, like which of those decision points will have the biggest effect, like on the results, and specifically for the infant data or the toddler data, which of those do you think will be the
Yeah.
biggest difference between those choice decision points?
Yeah, thank you very much. This is a very important question, also because it's one of the aim of the multiverse is like moving towards a shared pipeline. So it's very crucial to understand which step has an impact. So far, I confirmed applying the multiverse to such an incredible rich data set of the ManyBabies 2. I confirmed that the step that really impact a lot the results in a dramatic way is the exclusion of extreme values, even if they are a bunch of them, but they really can drag us to completely different interpretation, but mainly in the infants data, not in the adult data. That's also very interesting. And whereas so far the baseline correction seems not to have any important impact. And I was quite surprised about that, because when I started this work, I thought that the baseline correction would have been the most impacting part, but empirical data are proving me that it's not like that. And of course, the inclusion of participants that has a direct impact on the sample size, or the power, statistical power, of course, but also in terms of move the estimate in different direction. So far, these are the main degrees of freedom that I found critical. Yeah. And of course, also the filtering of the area of interest. And this is quite, many labs already do that, but it's not always clear in many pupillometry studies. So one suggestion that already came from this investigation, and it's very important to visualize raw data and to explain whether they have been filtered or not in terms of space. Because the eyes, especially for pupillometry, the degrees of the angle, the visual angle, may have a direct impact of the measurement, because the tracking works, measure the diameter in a way when we look direct at the centrum, and when we move our eyes, the measurement itself change. So it's very important to give a look to this.
Great, thanks. That's super interesting. I'm thinking myself, I imagine a lot of folks here are too, about all these decisions I've made in the past and how they might have affected things inadvertently. Any other questions for Giulia?
Yeah, following up of what you just said, I think that we should not be ashamed of this. I mean, this is part of science. I mean, revolution in science, changes are always there. And the fact that we now acknowledge this and try to solve this issue is just great. Because we have a lot of work to do together. So to me, the fact that we have shared problem, that we all have faced the very same issues, it's great. Make me feel less alone, right?
No, absolutely. I love what you have highlighted, which is just the transparency of this and the sort of careful documentation of these decisions that often don't get reported or get reported, without any justification in manuscripts. It's like, oh, we did this filtering and there's no discussion of why that parameter was chosen or maybe it's just the way that that lab's always done it, and so I really love this approach of making it very transparent and explicit what decisions were made and how those decisions affect the results. So thank you for sharing this with all of us. If there are no other questions, we can.
We do have a question
Oh,
in the
Quinn, go ahead,
Q&A
please.
just now. How do the degrees of freedom correspond to the simulated points above in the Shiny app?
Yeah, so for the Shiny app, it's just a toy. So so the data there do not talk about the actual project, actual data, and I use this like a way to preserve myself of any speculation, right? While doing method. When I'm working on methods, I prefer to focus on method and on being like biased or attracted by the results interpretation, because I'm a human, right? Even if I want to be transparent and correct and open scientist and whatever, I should admit that I'm a human. So I prefer be blind when I work on method, so that I know that the method is inspired by method and theory and not by data. So yeah, but soon, I mean, we are working on this Shiny app to make it available for everybody. So soon you will be hopefully able to explore the actual results of the multiverse. Yep. Thank you, Anna.
That actually makes me think of one more question. Could you maybe talk a little bit about how you all generated the simulated data that you use to develop the pipeline? That might be something that's new to some folks.
Yeah, hello. So at the very beginning, I just use all data set that I mean, I work with pupillometry since a while, so far since my PhD in 2022. So I use this data set, uninformed data set that just have real data about real physiology and problems, because we also have missing values problems with infants, right? So if we compare adults and children, toddler data sets, we can, I mean, we don't have to be expert to see that they are very different in terms of missing value. So I decided to start from these data sets, and then once the data were available, I simulate a new data set using just like the descriptives of the real data sets. So that are informative, but not that informative about the actual results coming from. So I was able to see whether the two simulated data were similar in terms of psychometric properties. And yeah, I hope I answered it.
One participant has a similar question, but they also ask, do you filter out some universes if you're using simulation?
Let me think about it. We discussed a lot about the moving average, because there were a group that wanted and another that doesn't want it. Now we are actually discussing and implementing a new degree of freedom, that is the zeta value filtering, and this will be part of the deviation of the pre-registration, of course. So yeah, it's a dynamic environment system. It tries to organize all these possibilities, this garden of path, but stay open. So there is rigor, of course, but also flexibility, and transparency is the key in order to be both rigorous and flexible. So I'm rigorous at the beginning, trying to doing the things as one should do, but then reality again is much more complicated, and you usually deviate from the pre-registration. I think that is a proof of that everything is working when you find some errors, some issues, and deviate transparently. It looks like it's true. When everything works too well, I mean, and so sometimes it seems too good to be true. So So we started with an idea, basically from the paper First Steps toward on behavior research methods, and then we modified, also trying to incorporate to put together, to merge together all the tradition that came out from different laboratories. So it's potentially the multiverse can increase in the future because everything will be open, and so one can say, I will at this point, and that's totally fine. I mean, but at the same point, we should be parsimonious in the sense that Gelman-Stigen, 2016, the paper that I really encourage you to read, is very clear about that. Do not make the multiverse explode, because otherwise it becomes computational, not usable in a way, and also for us, for our cognitive system, if it explodes too much, is hard to manage. So the parsimony in life, in statistics, and in science is always a good principle, I think, as Gelman said. So yeah, try to be parsimonious, so do not renounce to some branch. Exploring a part of the multiverse is better to not explore any multiverse. So even if you have just 2 branches, it's a small multiverse. It's better than nothing. To me, of course.
Awesome. Yeah, I really love that point you made about, deviating from pre-registrations transparently. I think a lot of people are scared away from pre-registration in general because they think it means that they're locked into something, and what if you find a mistake or change your mind about the best way to do it. And I think that's a really great point, that it's like, oh, if you can deviate, but you just have to document it and be transparent about it. Marlena has a question. Go ahead, Marlena.
She's one of the co-authors.
Thank you. It's good to see you, Giulia, and thanks for the talk.
Yeah.
You briefly touched upon this a little bit. I was hoping you could say a little bit more about, we've had the opportunity to work on these big data sets with very rich data, so the multi-lab approaches, right? So that you definitely have enough power for all of the different forking paths and everything. Maybe you could give some recommendations for if you have just a single data set, especially because earlier you also said, okay, including versus excluding participants makes a big difference in terms of power. So I think oftentimes we're working with data that is possibly underpowered, if anything, even if you just kind of take one approach. So maybe you'd like to say a little bit more about that.
Sure, thank you very much. Yeah, I think that each dataset is a part of the future multi-lab. So if we take care in sharing a dataset, even if it's underpowered, one day it will be part of a big family with other datasets. So I think that it's really a change in culture. So the thing that I do are not good per se, do not die here, but they have a future, hopefully. And so if I'm very transparent about, and I don't like these things that we need to have always the big data, this push toward power analysis to have power, but sometimes we cannot afford this for many reasons, practical reasons. So instead, and we need this power to make inference, because we do have to make inference, conclude stuff. But the conclusion are for maybe the future, or we can have tentative conclusion, evidence, description, robustness. We can have a lot of things that are very important as inference. But if you really want to have good inference, I think that we already have, I mean, ManyBabies and other initiatives are doing this, starting building the future. So in a way, each of our study can be part of a multiverse that will be a multilab. And if I also can add another thing, Marlena, yeah, the point is also the inference we do needs a multiverse first. Because what the multiverse teach to me is that a conclusion based on a pipeline is just, it's not the whole story. And so even if you have your small data set, I really encourage you to, I think that you already do this, encourage you to explore your data in a more systematic way, because I learned a lot from the data, also in terms of psychometric properties of the actual data. So it saved time, because once you have structured everything, you have the entire picture on your hand, and otherwise you each time do a thing, then you forget, then you save with a strange name and all the possible pipeline, and you end up like, wow, which is the real result, which was the real pipeline. So it saves you time and preserve your health. In my view. Thank you very much for the question.
We have one more question in Q&A. What do you do when your multiverse analysis doesn't point to any clear conclusion? Do you just conclude that you didn't find anything, or do you still pick some things that seem promising and report them? So what are your criteria to comfortably say that you actually found something that's true?
Great question. Thank you very much. Yeah, there are several ways. The most statistical sounding way is using PIMA, so post-inferential multiverse analysis. You will find more resources on the slide. So allows you to quantify in a way this fragility, robustness, and test actually which universe is different compared to others. So if you think you are confident enough to make some inference conclusion, you can do it using PIMA approach. That also is very nice because it preserves you from multiple comparison, because of course the bigger the multiverse become, the more results we have. So we inflate a lot the error one type 1 error, sorry, translating in from Italian, type 1 error. So yeah, the PIMA also control this and reduce the likelihood of type 1 error from one side. On the other side, I would never say that I didn't find anything, because as statistics again suggest us, the null hypothesis is always false, because in nature there are no two things that by which the subtraction is equal to 0. So and we know from the approach from Neiman Pearson or Fisher approaches to statistical analysis that we can never conclude that effect is not there. We can just conclude that we did not find evidence for the effect. So suspend our judgment. So we can never say there is no effect. So this is, so first of all, and then I like that the aim of the multiverse is not indicate which is the statistical significant result. Gelman said that we don't care about it. It's very radical, but the main point is to appreciate the distribution, the deviance, the distribution, also the magnitude of such fragility or robustness. So usually I summarize it by using a plot that show several statistics, like for instance, the Aikaka information criterion that inform us about the plausibility of a model, and so to look for robustness, looking at different aspects of and may in an exploratory fashion, the best things you can do is reporting also percentage of models that point towards a conclusion and the percentage of models that points towards opposite conclusion, and also describe very well which model, I mean, they result from which path, because this already is very, very so far informative. But yeah, this is a crucial question. Thank you very much, because this is an open problem. And if you think about some solution, write me. I would love to work, because yeah, this is summarize the multiverse results. It's a challenge, very exciting challenge. And so I don't have a final answer for this, but there are many ways to quantify the results, bearing in mind that there's no way you cannot find anything. Something, you are always collecting some information.
We have one participant who wants recommendations on learning resources for doing simulations for this type of analysis.
Yeah. In Psychostat we do Zoom, online Zoom meetings bi-monthly, so 2 times per month, and we talk about simulation a lot. In the site of Psychostat you can find a lot of resources in R, in Python, and in Giulia, maybe, that is, you know, this new language, an open source language that's coming up with simulation. I think that also our project itself has many tutorials on this, not sure. Yeah, but yeah, apart from that, I do not have any specific resources I can put the, no. I learned thanks to my collaboration with statistician. Yeah, my advice would be that find a statistician and become his or her best friend, because that's great. Interdisciplinary knowledge is the best. So simulation is funny.
I think that's great advice for us to end on. Find a statistician and become their best friend, and see what wears off. Thank you so much, Giulia. What a fantastic presentation. I learned a lot. I'm sure everyone else did too. And with that, we will end this event. We hope to see everyone at a ManyBabies event in the future.